Good morning, Year 11s. I hope you all enjoyed the test yesterday and I look forward to reading them this weekend. Today we are starting Pythagoras, and for the double we'll have a hopefully not too long video, 10-15 minutes, and I'll get on to difficult Pythagorean problems quite quickly because I know you've touched on Pythagoras first in Year 9 and then did it quite extensively in Year 10. Firstly, can you get out your notebooks and copy down the little diagram and equation I have on the board? That should all be relatively new to you, and remember that this triangle needs to be a right angled triangle, so include legs like that. Now, rather than going over the absolute basics of Pythagoras, I thought I would show you an absolutely cringeworthy YouTube video which should jog your memory. So, enjoy.
It's mathematics. Step into class, and by the time the bell rings, I hope you're ready for maths. In a right triangle given two sides, use the Pythagorean theorem you can find unknown values, so you have three. Label all the sides with an A, B, and C. Yo, looking for the C? This is where you find me. I am that side right across from the 90 degrees. The angle with the little square, shaped like an L for the legs that are there. We call them legs, what we call the third side. It's the hypotenuse. Say it if you heard it right. Hypotenuse, longer than the other two. So to find the missing side, here is what you're gonna do. Set up this equation, C is on its own. Of the three numbers, it is always alone. It goes A squared, yeah, plus B squared, yeah, equals C squared, yeah, that's right. Use the Pythagorean theorem you can find unknown value, so you have three. Label all the sides with an A, B, and C. In a right triangle given two sides, use the Pythagorean theorem you can find unknown value, so you have three. Label all the sides with an A, B, and C. A squared, yeah, plus B squared, yeah, equals C squared, yeah, that's right. Yeah, use this equation when you find out your side. Yo, here's a way to do it when you're given both legs. Square them, add them, see what you get. Take the square root of that, that's the last step. Now you just found the hypotenuse, right? It's a little different when one leg is missing. Set up the equation, everything in its position. Square the hypotenuse, same for the leg. Subtract the smaller number from the bigger one to get down to this last step. Take the square root. So I'm pretty sure that you know what to do, right? It's the last step, take that square root. Now I'm pretty sure that you know what to do, right? In the right triangle given two sides, use the
And that is quite enough. A squared, yeah, plus B squared, yeah, equals C squared, yeah. You will not forget that in a hurry, I hope. Now, I want to skip the most basic problems because you've done them before, so straight away I'd like to move on to a slightly more difficult problem. Can you please copy down this problem in your notebooks, and we are going to find x. Now, what you may notice about this is that x forms part of this triangle here. And in order to find x, we need the other two sides. That one and this one. Our issue is that we don't have two other sides, we only have one of them. So in this problem, our first step will be to find this side here. I'm going to call it y. Once we get y, we can then use the right-hand triangle to find x. Okay, but first we must find y. So, with all the problems we do, nice and systematically with nice clear working. Start with the equation. A squared plus B squared, yeah, equals C squared. Now, we label the triangle with the sides we have. It doesn't matter which way around A and B go, as long as C is opposite the right angle. So this here is C, A, and B. Now substitute in the values. 7 squared for A plus 8 squared for B equals y squared for C. 49 plus 64 equals y squared. Do the addition is 113 equals y squared. And now last step, square root to find y. Y is equal to the square root of 113. Now if you put 113 into your calculator, you will come out with some horrible decimal number between 10 and 11. But we don't need to use a decimal yet. Simply, we can leave it in the square root form, and that becomes quite convenient, and I'll show you why in a second. So we know that now y is equal to the square root of 113. All right. Now, finding x. So, once again, we start with our equation. A squared, yeah, plus b squared, yeah, equals c squared. All right. Using our new triangle now, we have a new a, a new b, and a new c. C is this side here, because it's the hypotenuse of that triangle across from the right angle. We have an A and a B. But now we know what our B is. Our B is the square root of 113. So we start off with x squared plus the square root of 113 squared equals c squared, c being 12. All right. X squared plus. Now here's where we left it as a square root, because the square root of 113 squared effectively cancels out each other, leaving us with just 113. That equals 12 squared, which is 144. Okay, now we solve for x. So we take away the 113 from both sides, leaving us with x squared is equal to 31. Square root both sides. X is equal to the square root of 31. All right. If you put that in your calculator, you'll come out with some decimal between 3 and 4. Sorry, between 5 and 6. But we don't need to. We just can leave it as a square root. It is the most accurate form to leave it in. If we had units in the problem, we could simply write that x is equal to the square root of root 31, for example, centimeters. If the problem specified that it needs to be to 2 decimal places or 3 decimal places, then by all means put root 31 into your calculator and round it off. Other than that, leave it as root 31. Next type of problem is now in 3 dimensions. Once again, take a second to copy down the question. Once you have copied it down, unpause me. Alright, this is a cube of length 2 meter, of sides of length 2 meters. What that means is that every single one of these sides is the same length, and they are all 2 meters. B is at the center of one face, and A is an opposite vertex. Those points have been marked. Find the distance from A to B. All right. So it is asking us to find the distance from here up to there. Now, there are 2 tricks with all Pythagorean problems in 3 dimensions. The first trick is form a right angle triangle. The second trick is pull that right angle triangle out of 3 dimensions and write it in 2 dimensions. All right. So there are a couple of different ways we can go here, but the way I'd like to do it is to say, all right, if I draw a line vertically down from B to get to the bottom, and then another line from A across the floor to that vertex. My drawings aren't beautiful, but they'll do. What I've created here is a right angle triangle. Because I dropped a line straight down and I had another going along the floor, that there is a right angle. And what we're trying to find is the distance between the A and B. So I'll call this side X. Now, in order to find X, we need the 2 other sides of the triangle. One side is easy. The height we know is 2 meters. And we know that because this here over here is also the height. What we have more of an issue with is this one along the floor here. You'd be tempted to say it's 1 because it's halfway, but it's not. This distance here is 1 from the corner to the center of the line, but this distance is more than 1, and I'll show you why in a second. Whoops. Sorry, technical issues here. Go away. All right, so first we need this lower leg here, which I'm going to call y. Now the question is, how do we find y? Well, y is part of a right-angled triangle itself. If I draw a line from the center of the bottom here, out there, this creates a right-angled triangle. And we know two sides of this right-angled triangle. We know that this is 1 centimeter here, because it's half the length between the 2 points, between A and the right-hand bottom corner. And even though it doesn't look it, we know that that in there is 1 centimeter. And the reason we know that is because B was at the top in the dead middle, meaning 1 centimeter away from this side and 1 centimeter away from this side. And if we drop a line vertically down, this landing point here must be 1 centimeter away from this side and 1 from that side. All right, so we have our first triangle to work with, which will find us y. So, having drawn triangles on the diagram, and don't attempt three-dimensional questions without a diagram, the second part of this is to take the triangles out. So what I'm going to do is take out this triangle here, and we're going to solve for y. Simply put, this triangle looks like this. Oh dear. I'll just do it by hand. 1 centimeter, 1 centimeter, y. Our right angle is here. We know that that's 1, 1. Sorry, I've changed units here. We're meant to be in meters the whole time. One of you guys would have corrected me there. 1 meter, y. All right, now we're in 2 dimensions. It becomes easy. A squared plus b squared equals c squared. 1 squared plus 1 squared equals y squared. 1 plus 1 equals y squared. Y equals, add the ones together, take the square root, so square root of 2. Now, square root of 2 really is about 1.41 something. It doesn't matter. We want to leave it as root 2. Okay. Now, we take our second triangle. Our second triangle is the one involving x. Along the base here is y. Up is 2 meters. And here is x. Once again, we have a right angle. And I'm sorry, my drawing's gone a little off the screen. Write the equation. A squared plus b squared equals c squared. This is a, b, c, crossing the hypotenuse. A is y squared, but we know, fortunately, that y is root 2. So we can write root 2 squared plus b squared, which is 2, equals x squared. All right, now root 2 squared is just 2, plus 2 squared is 4, equals x squared. Therefore, x is the square root of 6 meters. Okay, now I know those two problems are reasonably difficult. In the textbook, you start easy and work your way up to more difficult problems, like these ones. Do check your answers as you go. You have the rest of the double and tonight's homework to get through those sets of questions. That's Pythagoras in 2 dimensions and then 3. Help each other if you need. Any questions that each other can't answer, feel free to YouTube it or wait till I get back on Friday. Thank you.